Hello and welcome to Group 8's presentation for National City Bank. Group 8 is made up of Brandon Gormley, Adan Orozco, and Jay Weier. And today we're going to talk to you about our customer propensity model that we created. The objective of this project was to identify the top 100 prospects who might accept a loan offer based on historical data. So we looked at that historical data, we cleaned it up using exploratory data analysis. We then enriched that data with supplemental customer information to create one large set of data. We then identified variables that were highly correlated with acceptance rates of these loans using correlation plots. And then we created multiple models to challenge each other, and we were able to identify the most optimal model for predicting those top 100 prospects. The data sources that we used, the first one was our primary data was our current customer marketing results. So this contained a number of different fields of previous marketing campaigns and obviously their results. We then took supplemental data such as customer profile data that included their digital habits, their age, things like that. We combined it with that primary data, so then we had a slightly larger data set. We then added in credit score data, which talked about whether they had loans, whether they had balances on their loans, whether they had defaulted on their loan before. Again, we joined that into that primary data and the other supplemental data. And then lastly, we joined in the vehicle data, which told us what are these customers currently driving in terms of their own vehicles. So as I said before, we combined all of these types of data into one big matrix, and that's where we started to do our EDA, and that's what we built the models off of. So Adan is now going to talk to you about some of the details of the EDA or exploratory data analysis that we did.
Thank you, Jay. So we begin our EDA with replacing blank observations with NA. And after that, we started analyzing what variables were missing in the data and realized that a total of 3 variables had significant data missing. We had to remove the variable outcome for our current customer data due to it having 76% missing variables. And in our Axiom file, we removed both race and annual donations variables with 76% and 88% missing observations, respectively. After this, we did some further exploration to find some high frequency or noticeable information. Next slide, please. We created bar graphs and histogram plots, as well as correlation plots with our output. After this, we joined the data and ran comparing ratios to see exactly the number of interactions a set observation had and the success it had relative to our acceptance loads. The purpose of this was to see the effect that our categorical variables had on the data, since our correlation plots could only observe the correlation with numeric data. After this analysis, we decided to eliminate variables that provided no significant effect to our dependent variable. Next slide, please. As you can see, we dropped several variables due to different reasonings. Basically, as I said before, outcome and race and annual donations were dropped because of large missing variables. Head of household gender, digital habits, affluence purchases, and pets purchases were variables that were not correlated at all. So we did not see any significant information from our success ratios. And communication was dropped because of a high rate of missing observations. And we also decided to drop car model because we referenced our dictionary and we saw that car model and car make had the exact same definition, which left us to suspect that using these 2 variables would produce multicollinearity. Additionally, in our compare ratio function, we detected that it had high levels of dispersion and no obvious correlation. Thus, we decided to use car make, and the other variables had too many observations, which would suspect us to cause overfitting in our models. At this point, we completed our EDA, and now Jay will talk to you about our predictive modeling.
Thank you, Adan. So the 3 models that we looked at to try and solve this problem were a generalized linear model, a k-nearest neighbor model, and a tree model. All of these models are great models for predicting a binary outcome, which we had in this case, which would be a customer either accepting or not accepting a loan. And so now I want to go into a little bit about the generalized linear model and talk about how we created that model and how we optimized it for this task. So the generalized linear model, you can see on the right here, we have a visualization of a confusion matrix. And on the top left box and the bottom right box is essentially the numbers of predictions that it got right. And then the bottom left and the top right is essentially the numbers of predictions that it got wrong when it was tested against our test data. So how did we get there? Well, first, as Adan talked about, we had already removed car model, but we also found that car make introduced a lot more variables into this linear model and also reduced the accuracy of it. So we went ahead and removed that. We ended up boiling down the data to 14 valuable variables. Then when we ran our data treatment plan on it, it expanded to 21 variables. We optimized for a cutoff value of 0.7, and all of those settings gave us an accuracy of 66.4%, which is visualized on the right-hand side with the confusion matrix. So the next model that we ran was the KNN, and I'm going to hand that over to Brandon to talk about that.
Thanks, Jay. The next model our team decided to evaluate was KNN, or K nearest neighbor. The basic premise behind this model is to attempt to classify a given record based on how similar it is to other closely related records based on a number of predictor values. This measure of similarity is measured in units defined by Euclidean distance. The pros of this model is that it is data-driven and removes biases and heuristics. The downside of using this model is that it is time-consuming in that each new record which is evaluated is scored against the entire training set of data. One of the benefits to the EDA work that was done was that we were able to streamline our focus on the 11 most correlated variables and exclude the non-important variables from the KNN model. This not only increased the accuracy, but allowed the model to run more quickly. As we view the results, one thing to keep in mind with this model is that KNN makes no assumptions about the data. It includes outliers as well as non-normal distributions. The model utilized testing and training data partitioned at 90%. After the model was run and plotted, the number of nearest neighbors optimized at 13 given a tune length of 5. As you can see, the graph continues to increase in accuracy as the number of neighbors increases. The KNN results were then used to calculate accuracy. Initially, it was looking like the KNN model was going to be very valuable as the accuracy value for the training data set was equal to 0.701. Unfortunately, when this same calculation was run with testing data, the accuracy dropped to 0.589. Ultimately, we chose not to use this model for two reasons. Although this model did return a modest accuracy value, our other models returned higher values. The second reason was based on overall comfort with the model. Our team felt that we could be running into an overfitting issue as the accuracy trend continues to increase as the number of neighbors also increases. Adan will now explain the tree model.
Thank you, Brandon. For my tree model, I decided to avoid overfitting by setting the minimum number of records in a terminal node at 30 and a maximum number of levels to be displayed at 8, and a CP of 0.001 as well. Based on my results, we can see that there's a good consistency in the model because our accuracy in training data, which is less than our accuracy that's in my test data, which indicates that I'm not causing any overfitting. I can also see some consistencies with my root mean squared error, which is telling me that my model is providing great results. I can also see that in my model, I used the print CP command, which allowed me to see the CP units, and the 0.001 CP is giving me the lowest cross-validation error. I also decided to choose the smallest tree within a standard error of the minimum X error tree, and this allowed me to provide our best prune tree. And here we can see the probabilities of our outcomes based on the variables that a customer happens to qualify for. We have a total of 6 terminal nodes giving 6 different probable outcomes. As an example, I'll use the top percentages of the polar opposites. Terminal node number 4, a person contacted in the months mentioned with insurance has a 72% chance of not accepting the loan. And in terminal node 21, we repeat the same pattern with contacted months mentioned, no insurance, less than 18 days past, but they were contacted again in the different months within December, October, March, and September. And this person has an 84% chance of accepting the loan. Next slide, please. We decided to use the linear model because the tree model is only able to predict through ones and zeros. So we are not able to identify the top 100. We're only able to identify 100 options. Since the splits are done one predictor at a time rather than on combination of predictors, the tree is likely to miss relationships between predictors. Thus, we chose to follow the linear model despite the differences in accuracy. Now, Brandon will talk about the results we achieved.
So over the course of the project, our team observed a number of attributes of potential customers which may be insightful to build personas for National City Bank to leverage in future marketing campaigns. The first attribute we found to be highly correlated is education. As you can see, we see higher success rates with tertiary levels of education or of customers who do not provide this information. Next slide. The second customer attribute we identified with high rates of success were found with customers who did not identify with having household insurance policies. Next slide. The third attribute was based on customers who have car loans. The observation our team made was that customers who do not currently have car loans have higher success rates when it comes to extending a loan offer. Next slide. After returning the top 100 unique customer IDs, our team thought it would be valuable to look at the attributes of these customers to validate our own assumptions based on the exploratory data analysis and models. Next slide. This graph not only validates our observations, but demonstrates the importance of education on a go-forward basis. As you can see, we were able to validate that tertiary education levels are more prominent, followed by secondary and primary. This particular visual also layers on car loan as a fill to show a third dimension. At this time, our group would like to thank you for the opportunity to share the insights we've gathered in hopes our deliverable assists National City Bank in increasing their conversion rates to prospective clients. Thank you.